I'm going to start off with just a couple of additional things about OpenMind. We do everything through github.mit.edu, where also sits the OpenMind wiki. And talking of what Todd asked, this Getting Started guide gets you started with various things. But often, as with many guides, it doesn't get updated. So if you notice something that doesn't work, this entire wiki is editable by anyone who's on OpenMind. So I'd like to request that you as the community, if you see something that's incorrect, wrong, ask and use. The other thing that I'd like to point out about OpenMind is there's a Slack team called openmind-46.slack.com. Anybody with an MIT account can join this team. And since an MIT account is required to log into OpenMind, everybody here should be able to join the team. So over here, let's quickly check if Todd's question is actually answered. No, Todd's question is not answered. It requires one more piece of information, which says that you need to use XFCE as the window manager. But Todd will someday explain to you or update this to say all the settings that would be used to connect an X session and X desktop remotely to OpenMind. But I'm going to here focus on something else. So let me get started with Singularity. Okay, before I actually do this, I do want to point out that, again, in this wiki, go down and it says using Singularity. That itself has a link to this presentation. So you can follow along if you needed to copy and paste commands from the presentation on your own computers. You can open that presentation. I'm going to go through things over here. Okay, so Singularity on OpenMind. I have to thank a lot of people, but I realize that this is way too dark given these light settings. Luckily, most of the rest of the presentation is going to be on white background, which should be visible. So how do we get to Singularity? A lot of us deal with very complex software environments. So if you think of it, each project, I'm not even saying a lab, each project in a lab depends on operating systems, drivers, various software dependencies. They could be Python, MATLAB, R versions, glibc versions, which has come up for those of you who have been around on OpenMind for a while. Every once in a while, you want to run something, and it says glibc greater than 2.17 required and not found. And then you also have dependencies on various different software libraries and executables. Okay? Each project has its own timeline. So somebody in the lab may have started a project at one time using a certain set of libraries. Somebody else comes along a year later or 2 years later, software has moved on, and they want to start their own project with the latest and greatest in terms of software. In a complex system like OpenMind, it's going to eventually start clashing. There's no way you can maintain complex software environments easily. We've done a reasonably good job so far, but OpenMind is now about 3 years old. And in about 5, I would say if we didn't do anything, we would start hearing a lot of complaints. Also, doing repositories like that is very much 20th century. So, reproducible research requires consistent computing environments. So this means data and code and compute environments. So you can't leave any one of those pieces out for reproducible research. And parsing environments has typically not been straightforward. So imagine, I'm sure somebody in some lab has decided to run something that some other grad student or postdoc wrote and wanted to run it and ran into, oh, I have no idea how to set up this piece of software, or had to go through an extreme set of instructions to create that environment. So this is really where virtual machines and container technologies kind of come in. They allow you to encapsulate the entire computing environment, and more generally, they allow you to regenerate computing environments. So just like you write code to do analysis, you can write code or scripts to generate environments. And that makes it much more scalable, and you also get to understand what went into the environment. So you don't set up environments that just contain every piece of software possible on the planet, but things that you need for your task at hand. Okay, so broadly, they're virtual machines and they're containers. And I'm going to go into neither in detail today because I asked you to read something which covers some of the aspects of virtual machines and containers. That being said, we are going to look a little bit at VirtualBox, which is a virtual machine software that's installed on OpenMind. Those of you who've used Amazon or Google Compute or other things, those are effectively virtual machines. And then there are containers, and how many here have heard of Docker? Okay, that's a large representation over here. There are all kinds of other container technologies around. Today we'll be focusing on Singularity. And for those of you who really want to understand the differences between Singularity and all of these other things, you can click on that link and then that'll take you to Singularity, and it goes through a whole list of FAQs on how Singularity is different from those other things. But those details often matter depending on what you're trying to do. Here, we're going to focus on what we can do on OpenMind and how Singularity plays into that. Okay, so the ecosystem we have at hand is we have Vagrant, we have Docker. Since all of you are logged into OpenMind, or will be once you get your account, you know what GitHub is. There are two pieces. There's github.com, which is GitHub's main enterprise site. MIT's ODL has licensed an enterprise version of that, which is running at github.mit.edu, which is what we use for our wiki, which is what we use to submit issues to OpenMind. So keep that in mind. The github.mit.edu GitHub won't be able to do all the things that github.com can do. And when it comes to containers, some of the things I'll be mentioning will require you to create projects on github.com. So Vagrant boxes. So Vagrant is a scripting language around virtual machines. And it supports virtual machines that are virtual boxes, VMwares, and other things. On OpenMind, we have VirtualBox installed on every single node, and you have Vagrant installed. So you can spin up environments through Vagrant. Docker and Docker Hub has kind of changed the way people compute. Basically, you create a project on GitHub, you insert something called the Docker file, which basically says, this is how I want to create my environment. And you link that project to Docker Hub, and Docker Hub builds that environment and creates a container. So without SSHing or anything, you have access to a Docker container. So it's very nice when that's done. Now, can we do this all on OpenMind? Well, we can run Vagrant on OpenMind. There are some security risks, but those are mostly minimal, at least in OpenMind. But we cannot run Docker on OpenMind. Docker escalates to root privileges way too easily, and we don't want to give you guys root. That would be bad for our cluster, we think. Just accidentally bad. So this is what virtual machines on the left and containers on the right differ. So virtual machines spin up an entire guest OS on top of your host OS. So it's creating an entire new OS environment. Containers are much more lightweight from that perspective. It spins up the necessary libraries to create that host environment, but it doesn't spin up an entire OS and translate actions. So some of this was covered in that reading thing, but just to bring up, there's a big performance difference between containers and virtual machines. Okay, so we want containers. because VMs are too heavy, and Docker is not allowed on OpenMind. So how do we get there? Well, enter Singularity. So Singularity was built for HPC environments, and it supports containerized environments and reproducible science. Now, Greg wrote Singularity. Greg is the same person who wrote CentOS. He works for Lawrence Berkeley Livermore Laboratory. Gave a presentation. This was yesterday, so this is about a day old, and I'm not going to put this on. You can go through it by clicking on the presentation to understand a few more of the details of Singularity. Over here, what I want to get to is what's practical from the OpenMind context. And to understand this, we need to look at the Singularity workflow. There are two pieces, left and right. Left deals with container creation. And you cannot use Singularity OpenMind to create containers. You will need a Unix host or system to do this, because creating containers requires root access, which we are not going to give you in OpenMind. As we will walk through later, this is also where Vagrant kind of comes in. You can launch a virtual machine, have root access inside it, and create a container inside that virtual machine. We'll walk through that in a second, actually later on in this tutorial. But the most important thing is that you can run all kinds of images and containers without any root access. And luckily, there exists a lot of containers out there, thanks to Docker, that you can use. Okay. So those are the two pieces of the Singularity workflow. So let's start with an example. This was last week. I needed to send DICOMs, I do brain imaging work, for which I needed a particular piece of software called Store SCU. That Store SCU is in a package called DCMTK, which is not installed on OpenMind. And DCMTK is a hairy package. It requires a lot of elements to compile it. Or I could have written something in Python to do the same thing. Okay, so those were my first two options. Or what I did was I added the Singularity module, which all of you can do. You don't have to follow things right now. We'll get to that point in a second. I downloaded a container that was a Docker container and mounted my OM path into that container. And then inside the container, I was able to send DICOM images using that command, which I didn't have access to when I started. So no compiling, no writing Python code. I was able to reuse something that already existed and is well tested very easily using Singularity. Okay. And I didn't need to talk to a system administrator. That's also quite important, because we know that that process, for those of you, I saw multiple requests, give me an account, please go in at the beginning of this tutorial, that can take up to 24 hours. So any time we can avoid talking to a system administrator, that's a good thing, good place to be. Okay, so what are we going to cover in the next hour or so? Hopefully, we'll walk through some of these things. So just to know, the people who are not the people who've requested accounts, I would recommend that those people sit down next to someone, unless Matt has already created the accounts, which is unlikely, to follow along with things. But for the rest of you who have computers, will have access to OpenMind, right? Okay. So we'll talk about environment variables. We'll talk about running a Docker image. Again, given the ecosystem around Docker, we'll see how there's an extreme amount of containers available that should satisfy someone's need somewhere. We'll talk a little bit about how a Docker container and a Singularity image are different from each other. It's important to understand that as you work. So if you're just using containers, that difference is not as important. But if you want to create containers, understanding that is a little more important. And we don't run computers for HPC where we give it a Python file or some file which runs a giant simulation. Most of us deal with data, whether they are brain images or actual images or videos, which means we need to figure out how to get access to our data sitting on /OM. The third piece of this is how we can use GitHub to create these images. So let's say I don't want to run Vagrant to create an image. I can actually use GitHub directly to create these images, and we'll go through a couple of examples of that. We will talk about, for those people who do want to create an image directly on OpenMind, there is a way. So even though you don't have root access, you can get through some mechanisms to create an image on OpenMind. And then finally, this is probably relevant to a lot of people over here. One of the key benefits of OpenMind is that it has a fairly large collection of GPUs. And one of the things that you couldn't use virtual machines for is to access GPUs. Docker even couldn't access GPUs till about a year and a half back, when NVIDIA created its own version of Docker to create a layer to support GPU access. So GPU access till that point in time required you to natively access GPUs through the drivers. Singularity kind of has changed that concept. So you can access GPUs using containers. So you're in your own environment and you're accessing natively on the system. Now, I don't have a page over here which I can insert. One of the things that was written on those dark slides is that this is an editable presentation, so you can go and change things also on this and send pull requests. But one of the key elements of Singularity is that its performance is just like native performance. So there is no performance hit when you're running a Singularity container versus a native system. But there's often a performance hit when you're running a VM on top of OpenMind. Okay, environment variables. So these are a couple of things that are useful to keep in mind. This is kind of going through the pieces. We won't set these right now. They'll come about as we work through the tutorial. So there's a variable called Singularity cache dir, and it controls to save images. Now, as Evan noted, you only have 5 gigabytes of space in your home directory. Often you'll find these images larger than that, or a single image takes up 5 gigabytes. So you won't be able to write it out to Singularity's normal default location, which is your home directory. So you'll have to reset that, and you can point to OM, where you have a better storage space. $home is mounted into the container by default. So when you go into this container environment, your home directory is automatically available, but the rest are not. But it also means that anything that on the path variable, so on Unix systems, your path variable controls your access to all the executables that you have access to. If they were inside home, Singularity might pull those up even if you wanted a different binary or executable to run. So for example, in my case, I have a Python environment sitting inside my home directory. So when I launch a Singularity container, if I'm not careful and I just type Python, it picks up that Python environment from my home directory as opposed to the Python I want from inside the container. So it's important to keep these variables in mind. srun and sbatch, which are the two commands that Evan went through, one of the key elements of those two commands is that it carries your local environment variables over into the remote job that's running. Singularity does the exact same thing. And environment variables can have a huge impact on what you do. So there are ways you can turn flags on both sides. So for Slurm, you can set a flag which says, don't carry any of my environment variables over. And the same thing with Singularity. You can turn a flag on which says, don't carry my environment variables over. But if by default in your image, you're carrying your environment variables over, you have to be careful. Okay, I talked about virtual machines. There are two pieces to a virtual machine. Vagrant home is where boxes are stored, and I'll go over this in a bit. And machine folder is where virtual machines are instantiated. So a box is like an image that Vagrant downloads, and then it spins up a virtual machine, which gives you the new environment. And so these are in two different locations typically. So it's just important to keep in mind those things. All right, so now we could get started. So I don't think anybody's on OM Interactive right now because that's the least used node unless somebody wants to do other things. So I think all of you should be able to log into that. Also, it has a time limit of 1 hour, and we expect this to end in 55 minutes or less. So you should be also fine with logging onto it. What we're going to do is use srun to create a single job. If there are more than 32 people who are logging on, we'll run into an issue. But my general sense is we are right around that border. And you can mostly follow along, but there are a few things I've kind of put in over here which I normally wouldn't have for a Singularity tutorial. But since this is Singularity on OpenMind, there are a few components that are important. So yes, we add a module, and for the time being, we'll use module 2.2.1. So each module has various versions that are available. And Singularity actually currently has 2 versions available. We'll use the release version for about 90% of this tutorial, and over the last bit, we'll switch over to the blood-sucking edge version, which is the current master branch of Singularity. Nothing guaranteed, but it does do its job, and it actually has a couple of nice features. OM Scratch is your Scratch directory. You can create things in there, and every 3 weeks, each day of the week gets erased. So anything you want to persist shouldn't exist in OM Scratch, but that's where we will conduct this tutorial today. Because Thursday, worst case scenario, it dies Thursday. Best case scenario, it was cleaned up yesterday or today. So you have another 3 weeks. But either way, for a tutorial, it's great to use Scratch. So what are we doing over here? We're creating a set of directories. The whoami command basically says you're creating a directory or name so you don't conflict with anybody else on the system. Creating a directory called Singularity Tutorial. We're using an abbreviation ST, and then we're creating a cache directory. Since Singularity images could be large, this is sort of important to know in the context of our high-performance parallel file system. What this instruction is saying is, and this has to happen before you put things into that directory. It's important. Once you put things into that directory, you cannot change its type. So our high-performance compute system /OM appears to every one of you as a standard file system. But behind the scenes, the data are distributed across a lot of different machines. And what this command says is, for any file I store over here, distribute that file over different machines. So if you have large files, these might be in gigabytes, they get distributed, which allows more efficient access to the files. Especially if you have terabyte-sized files, you absolutely want to do this. Otherwise, it creates all kinds of bottlenecks if you're trying to access terabyte-sized files on the file system. Okay, and then we set this cache location to that variable. Then we go into the Singularity tutorial directory. So once you guys are in there, or I see a general show of hands. So that's a command. So these are backticks, and whoami is an actual command on a Unix system which returns your username. So if you were to copy and paste that command in, it would create a directory under your username. I was just trying to make sure that everybody didn't end up creating the same directory, which wouldn't have worked. How many people still haven't gotten to that point yet? A couple of folks. While those folks are finishing up, one thing you'll notice, I've tried to maintain a different prompt for whether you will be on OpenMind inside at a node or you're inside a container. I'll try to keep that in mind because we'll be moving back and forth between being on OpenMind and being inside a container. Okay. All right, I'm going to move on, and hopefully you all have access to this so you can copy and paste from the presentation itself. So the first thing we'll do is run a Docker image. But before we do that, we're going to look at what ls gives us on /etc. So /etc is a system directory. And if you do ls/etc, so we are still on that node, so node 17 that you've logged into, you're going to see a lot of different things in /etc. The only point over here is to keep in mind that when you do ls/etc, you're looking at this host/etc folder. And then we're going to do Singularity shell and execute that command. What's BusyBox? BusyBox is a very lightweight Linux image. And this is only intended to illustrate it, and so that when everybody downloads this, it doesn't take them forever to download a container. BusyBox tends to be between 1 and 5 megabytes, which should be very quick for people to download. But it is an actual full-fledged Linux system. And once you've done that, you should have been thrown into a prompt which says singularity.something. And now you can redo that ls/etc command. That should be something quite different from when you did ls/etc to begin with. Have all entered a completely new environment. Now, we can take a few more things. We can execute that command, who am I? So unlike various Docker images, where if you did this with Docker, that who am I command would tell you that you're root. Do who am I, it will still tell you you are yourself. You haven't become root inside this container. In fact, you will never be able to become root inside this container. And if you do ls$home, it still gives you and should give you the listings of your home directory. It has been mounted into this system. All right, so if you're done with that, we'll do the next step. We've gone from a lightweight image to a not so lightweight image. So this image is about 1 gigabyte in size. But as you can see, I'm still using Docker. So these images are built by Docker. So I can reuse a lot of Docker images. And I know a lot of people run TensorFlow on OpenMind, many of who are in this room. And I'm pulling in an image called TensorFlow. And this is their current release, 1.0.0. And it's built with GPU support and with Python. Technically, it doesn't have GPU support. It requires NVIDIA Docker to run. So you won't be able to run this on a GPU by default. But we'll get to that in a second. But if you do this, it should, again, launch you into a container environment, which has all of these things. And this is where specifying which Python is kind of important. Because at least in my case, if I just write Python, it'll pick up my Python from my home directory, and it won't find TensorFlow. Whereas in the container, it's at the default location, user bin Python. And this basically executes, and it should return nothing, because all it did was import a library. So for those of you who don't know Python, the intent of this is just to show that there's arrays. So even though you didn't have TensorFlow, very likely, you have now gotten access to TensorFlow as a package. No. So you're getting error messages.
Curious. LD library.
Oh, error messages from this step?
Yeah.
Yeah. So they're warnings. They shouldn't be error messages. OK. So this is the GPU version. So it's looking for libcUDA to run, and it can't find it. But that's OK for now. So as I said, this is about 1 gigabyte, and we have n number of people all downloading it and extracting it. We hope that it should happen in a few minutes. Did somebody else raise a hand? Yes. Absolutely. We'll get to that in a second. I wanted people to go through the pain of this a little bit. So currently, everything would be stored inside this cache directory, because that's what you've set things to. I'm going to go on to the next page while people are downloading things still. And this is the point that once you exit from that, you can actually reuse this. And for those, at least for whom you've already downloaded things, that should be instantaneous. But when you do ls/om, it should tell you, I can't find it. So you've downloaded a Docker container, but now you don't have access to OM, which is important, as we said, because we want to run on data that exists. So what can we do? We can go into this cache directory, make an omdir, just create the omdir, come back out. So this sequence of commands is important. I'm also trying to teach some Unix basics as I go along. So push temporarily takes you to a directory, pop gets you out from there. And now I've added an extra piece to that command. I'm basically saying mount/om from my local host into the container at this location/om. Go back into the container. And now you should be able to see your user directory with this command. So how many people are still waiting on that initial download? Wow. And there's no error, right? It's still saying layers. So the one thing that does come up when we hold certain tutorials is that because there's simultaneous access from a location to a place, they often think of it as an attack happening. And so sometimes we've had cases where everybody was blocked off from that IP address because there were simultaneous attack. Has anybody been able to download it? OK, a couple of folks. Your cache was empty? And can you echo Singularity cache dir and ensure? Well, maybe I can go on with the conceptual pieces and hopefully things will catch along at some point in time. So there are two pieces that happen with each of those layers. It downloads the layer and then extracts it. So both of those pieces are happening. Again, it should not take that much time. I've run through every single step over here. The file system?
Yeah, just running out.
Oh, another thing about OpenMind. So one of the things you should do is unalias ls. So ls by default has ls space dash dash color. And that dash dash color gives you a very beautiful picture of your directory. It tells you what's an executable, what's a directory, what's a flat file. But each of those colorifying actions require talking to the parallel file system and asking and doing a stat on every single file, which is slow. So if you unalias ls, it'll be instantaneous to get an ls or even a recursive ls on the directory. Okay, so we did get a more extensive image. Example 1. So the main thing over here is now we have a way of mounting our outside folder into the container. So sharing images, great for repeatability. As we can see, we have all these Docker images that we can use and share. But what if you wanted to modify that image? Let's say it wasn't the environment that you were directly looking for. You wanted to add a few things. Or you wanted to know what was inside that image. Where you want to look at what built this image, the specification that created it. And there are two types of specifications you can use. So every image that's built on Docker Hub has a Docker file attached to it that tells you how that image was built. And it's a set of commands, typically Unix commands which says install this package or do these things. It's a very straightforward set of things. Correspondingly, on Singularity Hub, where Singularity images are built, there's a Singularity file attached to each image. For both of these, for most things except for very private repositories, they're associated with open source projects, so you can go to GitHub where the typical Docker file and Singularity files sit, and you'll be able to see it. So for using either hub, you will need to create an account on GitHub and create a project that you then link with the hub. We're not going to go into this today, but the Singularity tutorials kind of walk you through this. But what we can do is take a look at such a specification. And here's probably one of the simplest specifications that exists, which is we are saying we're going to build this image from a Docker image. And that Docker image has a title Debian:5. So what can we do? For those of you who have never seen Docker Hub, go in and search for all kinds of things. So let's see. There's the official repository. So this thing over here where it says Ubuntu, that gives you the name of the image. And when we were doing Singularity shell docker : / we're effectively using this name. Now, in Docker, you also get various versions, which are called tags. You can get different versions of Ubuntu, for example. So if you wanted Yakety Yak or Trusty. What's Trusty's second name? I forgot his second name. But Ubuntu has paired names for each of these things. So you can get any of these specific images by doing Ubuntu : tag name, and that'll bring in specific images. If you're looking for almost any software that I know of, I think if you put the name in there, somebody will have created a Docker image for it. So it's really a very extensive repository of images. But that's Docker Hub. So here, we're saying we're going to take Debian 8.5 and create an image for it. That's as simple a specification can be. But you could do a little more things. So here, we're using not Docker, but we're using a command called de bootstrap, which exists on Ubuntu systems, actually downloading the image from the Debian repository itself. And within this script, you can now add a couple of different things. You can add a run script, which is, it'll execute that section whenever you run the container. You can have a post script. When you're building the image, it takes that image, executes all of these commands. So in this particular case, the default thing doesn't have this Vim package. So what this is doing is updating the repository pointer and then installing Vim. And all of this is in a file, and you can put this on a GitHub project, connect to Singularity Hub, and Singularity Hub will build this for you. So you don't have to do this. But you could also do this internally yourself. So let's take a few. I won't go into examples of Bootstrap files. This is a project I will go in. So I have set up a project called OM Images, the same place I'm serving that presentation from. And in GitHub, I have different branches. Each of these branches is a separate image that I'm creating. So one creates an image for TensorFlow, the GPU version, and that image actually runs on our system. Another branch builds this BIDS MRI QC image, which is something we use for brain imaging stuff. And then the master branch is just an example of a very basic system, Bootstrap. So if I look at the Singularity, all it does builds it from Debian 8.5, and it installs a bunch of different libraries onto it. That's all it does. It's just an example image. So by creating these Singularity files in different branches, I can then go to Singularity Hub. One of them will be OM Images. That I can click on or off which branch I want to build. So, yes? That's the next piece. So this part, I mean, are there any further questions here? We can come back to questions later on, but the general idea here is that you can build these images when thinking about OpenMind. You can create these Singularity files and have Singularity Hub create the images, just like Docker Hub creates images for Docker containers. Okay, we've gone through that. The Bootstrap files you could look into later. So this is where I'm going to answer Andrea's question. You can, if you have a Unix system, which if you're running OS X, you don't directly, you have a Unix system, but you can't run Singularity on it directly. You have to use a virtual machine. You have to have a true Linux-based system to run the Singularity create command, or you have to use a virtual machine. So on OS X, on Windows, if you want to create an image, you have to spin up a virtual machine, and then you can install things. So when it comes to Vagrant and VirtualBox on OpenMind, a couple of terminologies. So I use the term box and virtual machines. So Vagrant is the command which downloads, builds, and exports boxes. They're images. They're not running machines. They're not computational devices. VirtualBox creates and runs virtual machines. So it'll take that image, just like we're using Singularity to take an image and create this environment, VirtualBox does that. But as I noted earlier, it's a full-fledged operating system, so it's fairly heavy. But we can use it to create Singularity images. VirtualBox stores VMs in the machine folder, which defaults to that location, $home VirtualBox. And so you're soon going to run out of space if either of those things point to that location, because each user has that quota. Now, since there are people who have run virtual machines, I wanted to put this up here before you follow the next few steps. We are going to change the location of these things. So depending on whether you have or have not changed this, you should be careful about the next few steps. So we are going to change this vagrant home to $pwe/vagrant. Now, this $pwe simply means my current working directory, which I'm in, is still in that scratch location. And the second command, which tells VirtualBox to create VMs in that location as well. So we've basically pointed things to the scratch location for folks so that people don't. But this one is okay to do. The second one is the one that can have impact because it's a global flag for VirtualBox. If you are running virtual machines, then that execution process is not going to see this change and can cause some issues. In general, we build these virtual machines just to create images and then we shut it down. So most of the time we are not, but there are users over here, maybe not in this room, who do run virtual machines kind of continuously. Okay. The other piece I wanted to say was, how many people know what dev/shm is? Person. Okay. It basically is a file system that's based on your memory. Now, we have fairly large memory nodes. So if you create things over here instead of OM, you get even better performance. And for things, it actually makes a lot of sense because your worst case scenario is dev/shm writes out to the file system. So because if everybody started storing things on dev/shm, it'll run out of memory at some point in time. But your worst case scenario in that case is your file system is then your backup. So this is always going to be faster than this. And for many ephemeral things, it's actually quite useful to use dev/shm. Okay, so here, the only thing we're doing is we're using that silly, simple Bootstrap. And in post, we're making these mount points. Now, if you remember, in one of the earliest examples that I showed of how I used Singularity last week, I didn't create those mount points. I pulled a Docker image, and I simply mounted at /mnt, right? Because /mnt exists on every single Unix system. So I mounted /om on /mnt. If I change my scripts, then I don't really need to create these mount points. But if you already have scripts that are taking advantage of /om or /cm, then by mounting these things, you effectively have the same disk environment inside the container that you had outside the container. Okay, so what's the process? Well, the process is that vagrant init creates one of those vagrant files. And here we are saying I want the Ubuntu Trusty 64 virtual machine. Vagrant up brings that machine up. So you now have a full-fledged vagrant box running. That vagrant SSH command installs Singularity inside that virtual machine. And then finally, the vagrant SSH command now SSHs you into that virtual machine. And so now you're inside the virtual machine. So inside that virtual machine, this is the process by which you create an image. You have to use sudo, but now you can. You can be root inside. Yes? On OpenMind, correct. And we don't want to give people sudo on OpenMind for the same reason we don't run Docker. So we an image, and it's an empty image at that point in time. And then we issue that Bootstrap command, which takes that Singularity file. So our simple Singularity file was this file. And then once that's done, you have a Debian image. And then you can Singularity shell into Debian. It'll be inside your Debian container, inside your virtual machine on OpenMind. It's just a nested set of layers, but you really don't want to bring up this virtual machine to use this image every time. So you copy to /vagrant. Now, /vagrant actually is a mount on your local system that mounts inside the virtual machine. So you exit, and now you're back on OpenMind. You can do exactly that, Singularity shell debian.image. Because we did the mount, you will be able to see what's in OM inside it. You can exit, all things look good, and then spin down or destroy the virtual machine with vagrant destroy. So you brought up the virtual machine, created a container, wrote into the container that creating and writing required having root access, and that you had inside the virtual machine. Once you created the image, you copied that image because you now just want to read like a binary executable at that point in time. And you shut down the virtual machine. Okay, so here's the last piece of this, which is using Singularity with GPUs. Remember, we downloaded that TensorFlow file, which Todd clearly pointed out there's a problem with because it can't find the NVIDIA drivers. This Singularity file, if we go and look at this, pulls from that same Docker image that we downloaded earlier, but it does a few other things as part of that image. So we've downloaded, we are saying we want to bootstrap off of a Docker image, and this is the TensorFlow 1.0 release Python 3 GPU image. And all of that is built by Google directly off of the TensorFlow. So we get that. Then what we're doing is we set a few paths. That's not as important. We update our Ubuntu. So that Docker image is based off of Ubuntu. And this is the part that's relevant to OpenMind. It requires an NVIDIA driver that's sitting on our system. And so different systems have different versions of this driver. So here we say we want driver 375.20. Why do we say that? Because that's the driver installed on our system. How do we find it out? If you're running GPU stuff, you would know NVIDIA-SMI and other commands automatically list what that driver is. So if you were to run this on a different system which had a different driver, all you would need to do is to change this driver version at two places, there and here. Because of bash expressions, I can't use a variable name over here. You can't have nested variables in bash. But effectively, those are the two places you change the driver. The rest of the code is basically extracting downloading the driver, extracting it into the container, and then adding something to this environment file. And that's another important piece with Singularity. So every Singularity image has this /environment file. And you can add things to this. It's like your bash RC. When you run that container, things in that file get executed before you get to a shell or a process. So you can add new paths, you can add other LD library things, etc., directly over there. And then finally, I'm mounting two things which are relevant to OpenMind in there. And there's a section which has a test. When this runs it, it will import it. It might give warnings or errors that you may not have CUDA installed. And this run script at the beginning basically says, if I were to treat this container image as an executable, When I run it with arguments, what it's executing is /user bin Python with those arguments. So if I gave it a Python file, it would run that Python file directly. So that creates an image. To run it, as Evan pointed out, you will need to actually get to a node with a GPU. And to do that, you need to request one. That might be something, even if you've caught up with me at this point in time, which I doubt you have, you probably wouldn't be able to get to because other people are running things on the system. We don't have spare GPUs. I had asked for a reservation for these 2 hours, but that didn't come through in time. So that will give you a GPU. To pull from Singularity, I need to remove my old Singularity module and add this bleeding edge Singularity module. You could do it in other ways, but this allows me to, just like I did docker : // it allows me to do shub : // and it pulls this image that is being built automatically on Singularity Hub. But as Andrea asked earlier, you could take that Bootstrap file and create an image locally without having to go through Singularity Hub or GitHub. And then I can get hold of the image, mount the directory, but instead of retrieving this time, we can reuse that image that's already there. So this is the hash of the image, and when it downloads, it puts it in that location. And if I run this with convolutional.py, which is an example from the TensorFlow package, it runs pretty quickly. If you run it on the non-GPU version, it runs slowly. Run it on the GPU version, this runs pretty fast. And that's how you know it's using. It'll tell you what GPU it's using, and it runs quickly. And this is kind of boils down to that we can share these images. So it's important to now start thinking about how within a group or within the context of everybody doesn't really have to go through that pain of downloading every single image. If we have a local shared repository and we have a key value mapping which says, if you're looking for this image, this is the hash of it, then it's very easy to pull that image and reuse it. So that's the general conceptual framework on OpenMind. Since this is online, you can go back and your heart's content, repeat or go through it. I'm happy to take any questions. Let's start. So for some of those things, it's easier than others because some of them actually, so I'll repeat Todd's question. He has a complex environment. Can he recreate that complex environment inside a Singularity container when you don't have access to all the things that went into creating that environment? So there are a couple of ways one can go about doing this, which is that what we're looking at in terms of is we're thinking of these as applications or executables. So when you have your complex environment, you run various processes in it. And there are tools out there, standard Unix tools like strace or Python tools like Reproducible, which if you attach to a process, it'll tell you what you used out of your environment and package it for you. Once you have that, then you can pull out those packages into a container or create a container with the packages, and you would recreate the working environment. But a more fundamental level that we should consider is how those environments came to be in the first place. So moving forward, or in a prospective nature, we should understand what is it that we did install, because now you can just add that line, that install line, into that Singularity script to recreate that piece of the environment. Yes, Andrea. So if you're familiar with Docker and you have access to Docker, which I know you do, you can do Docker to Singularity, and it'll convert Docker images to Singularity images. The places where you want to be careful are things where it sets out environments and other things, because in Docker, for example, if you want to create environment variables, you have to list each environment variable on a separate line. So a key difference for those who don't know Docker is that Docker comes as layers. It builds a layer, and then it adds another command as another layer, and then another Docker command as another layer, and so it builds it up. What Singularity does is it all those layers and squashes them down into a single image, so it loses the layers. Now, this might change in future versions of Singularity, but for a moment, it just creates a flattened image. So it basically and that's exactly what it's doing with the Docker. When we say Singularity shell Docker : // it's pulling these layers, stacking them up, and creating the image. When you're translating a Docker file to Singularity file, I would say you really should think about what is it that the Singularity file is adding on top of that Docker file, and whether you can actually add those things in the Docker file itself, and then either pull from Docker or convert using Docker to Singularity. If are there any more questions? Not? There's one more. Okay. So so it depends on the technical capability of your lab mates. So that varies across people. I would suggest first point them to this tutorial, because I think this at least gets you through the basics in various ways. Once they're comfortable with this, then it really depends on what's most efficient for them. So for many people, I suspect just using the Vagrant box and building it locally is going to be fine. For other people who want to share that, here's my Singularity file, using GitHub and putting it out there is very straightforward and simple. You don't have to worry about it as it builds remotely. And then you can download it and use it. So it gives, I think, visibility. It allows somebody else who they're collaborating with access to that same image. And I think that's a better route to go for that kind of reproducible. I would start with simple things, pulling from Docker, much easier than doing the Bootstrap and putting all the pieces in. And Docker isn't going away anytime soon, I think. So it's good to know what's in them, but practically speaking, Docker ain't going away. Oh, yes. Yeah, this is all online.
That's all.
Oh, the first half as in Evans? Yeah. So I think both of these things, the videos will go online onto a website, and maybe Emily can. So Evan could put it somewhere if. All right. Thanks, folks. Made a mistake over here. So it was black, and when I hit it, I pressed exactly in the same location.